Okay everybody, in this video we're going to look at preparing the flywheel. So the CNC will machine out the spokes of the flywheel. What we need to do in advance is to prepare it, get the material to the correct thickness and to face it off down to size, and then machine the outside down here. So we look at our drawing, update your drawing to see what the correct thickness is. In this instance here it's at 30 millimeters. And we machine the outside diameter down to 150. We're going to drill a hole in the flywheel, and the reason we're drilling the hole in the flywheel is to allow us to machine the outside diameter so it fits into this picture here. And the size of that hole that we're going to drill, refer to your notes, it's drilled 19.5 and it's ream 20, and that gives it a snug fit down over the picture. So at the end of this video we're going to have our part ready to be able to pop in here to this picture, allow us to machine the outside diameter and then place it onto the CNC so we can machine it out and take it off the finished part. So to start off, the main difference to notice is that because it's a large material, it's over 150 in diameter, you've got to use external jaws. So to start this, I've removed out the internal set of jaws. So these are numbered 1, 2 and 3 and location on a self-centering 3-jaw chuck. So what we're going to do now is we're going to pop in the external jaws into the chuck, and to look at that they need to go in a specific way. So each one is numbered, so that's number 1, so that needs to line up into slot number 1, and that's identified here by the number there, 1, numbering system, 1, 3, 2 and so forth. So jaw 1 goes into slot number 1. So we wind around. Now a member of staff will do this for you, you don't need to do this in your advance, so a member of staff will have this done for you. Just ask your lecturer for help. So when the opening appears, you slide down your jaw, wind it back to hear the click, and then wind forward so it grips the jaw securely. Then checking the number is correct. Number 2 is going into slot number 2. So again, slot number 2, and I'm winding forward to get the opening. Have the opening, go slightly past, now wind back, hear the click, and then wind forward. So then I move on to jaw number 3, and repeat the process. And now I've cut all 3. So I'm going to verify that they are all closing in at the same point and meet in the center before we start machining. We want to check that these all close in, these 3 jaws meet together at the same position. Perfect. Now we can go back out again. Everybody needs to check that before you start machining, safety wise, that they definitely are put in the correct position. Now, the next procedure then will be taking our piece of material. We have to remove the saw cuts on both sides. On the first side, we need to move we're going to place into the chuck. So between the jaws, you tighten down in the chuck, and you're ensuring here that it's caught securely between the jaws. You want to ensure that there's no gap in behind here. We don't want a scenario where we've got to create a gap like this. We don't want that scenario, because that means it's not going to machine correctly. I want to make sure that that's in fully, and to do that, you take your hammer, plastic hammer, you're tapping back on the jaw, try to tighten, just to ensure that it's back up against the jaws, and it's in securely. And you firmly tighten up. Now, in terms of the tool we're going to use, that's normal carbide cutting tool, and we're going to, with this one here, we've got a facing off tool, specifically for this job, gives the better machining. This is the tool we want to use for facing off the part. That's the one you're normally using for facing off. This is the one we're going to use today for that material, aluminium. So set your tool height on center, using the revolving center. Ensure, in this instance, we need to raise up the tool tip. So we open the lock, and we're adjusting up the height to suit, and lowering it down if you need to. That hand needs to be open. So with the height set, that's perfect. We're going to move around now, getting ready for facing off. So we tighten up on the chuck. I've also extended out the tool in its holder, and I'm gripping about 1, 2 and 3, these top 3, and it's not being gripped by the back one here, to ensure we've got the maximum stroke with the machine right to the center of the part. Now we need to offset the top slide. at an angle of 15 degrees to suit. So we open this nut here and the one at the back. Then we offset the one 15 degrees, and that allows the correct clearance angle for the material to escape as we wish, as we are facing off the part. I'm going to leave off the coolant as I'm doing the video, but you can apply coolant onto the cool tip to cool the process. So the speed, according to your formula as you're setting it, is going to work between 370 to 540, and don't go above 540 RPM. So I'm setting my RPM here to 540. Now, according to our calculations from our formulas above, we know that the feed rate is dependent on the RPM. So the feed per tooth per inch is 0.2. So according to the calculation for turning, we see that the feed rate in automatic feed is N, the RPM, times the feed per tooth. In this instance here, we're going to set it to, the setting is AT8X, give it a 0.2 pitch, times our 540, it gives our automatic feed rate. So I've set that to ATX8, RPM is set to 540, part is in secured position, tool is set up correctly, and now we're getting ready to machine. So bring the tool over to the part, and the next thing you will need is what's known as the swarf hook, and also your brush. That's to remove any kind of the chips as they come off. So putting that ready for place, what I'm going to do now is going to touch the tool off the work to set my zero, or set our zero. Tool touching the work, we're going to set the zero in the machine, press this for the reference button, set to 0. Powering on the lathe for the first time, and now we're going to face across the piece out to the centre. So now they're out of the centre, you're removing the brush, and I said don't ever attempt to put your hand in there, it's always using the brush to feel where the chips, or using a swarf hook to catch the chips and see if they're continuous chips. Now the procedure is, we want to make a small facing off mount, so anything less than a half a millimetre. I'm going to get cut there about just shy of less than half a millimetre. So you change the direction of your feed here in automatic feed, pulling the lever out, set the direction to go across the part, so the X is going to go across the cross side, controlling the cross side, putting up the lever, and now you're travelling in automatic feed. Here's closer to the part. Now we're machining the part. Now as we're machining, now remove away that swarf. We're getting a very good finish here on our part. If I stop for a second just to see, with the correct speed and the correct feed, we can clearly see we're getting a nice mirror finish appearing on our part. So try use the automatic feed, as it will give you a better finish, a mirror finish on your material. So what we're trying to see is we don't want to see any saw cuts here, and we can see now we're going to continue on. So powering on the lathe again, and then engaging the automatic feed. Always stopping and starting the automatic feed before you stop and start the machine. And as the material is coming away, if at any stage it gets too much and it builds up, you can always stop the automatic feed, stop the machine, and then safely clear away the chip. I also recommend not to have the revolving centre in place to avoid getting any scratches to the back of your hand. So putting that out of the way and then concentrating on this job at all times. So powering on the machine again, we'll clear the leash and continue on. I'm leaving the coolant off just for videoing purposes, but you can apply it onto the tool. Now, if this happened at any stage, you stop the machine. What happens here is it's kind of building up on the on the tip of the tool, just need to remove that out of the way. Again, don't use your hands, just use the swarf hook or the brush to remove those chips. Now it's cleared out of the way. Also, you can get along those pliers just to snip away that material. So again, before you're starting, you're just clearing underneath the machine, making sure you've got no swarf chips. That's cleared out of the way. You'll need your brush at hand and your pliers to clear away. Powering on again. We're getting a nice finish here on the part, and we're going to continue on. So if you can keep it moved away, it won't build up on the machine if you keep it fed away. So you keeping it fed away from it will stop it from building up. So it takes approximately 2 minutes to reach the centre, according to our speed and our feed. It takes us about 2 minutes to make each cut. We're getting a very good finish on the part. I'm going to stop again, and I'm going to clear away some of that swarf. So again, I'm not using my hands at any stage, I'm always using pliers. I want to avoid getting cut. So it's important to keep feeding away that material to ensure it doesn't build up at any stage. Approximately 2 minutes to reach the centre for each cut. Pause. So as we're going to machining there now, we're applying the coolant on there, keeping it onto the tool and not onto the work, and we're getting an excellent finish on our part. And the material is called this continuous chip. That's a very malleable material, the aluminium. It's very easy to machine. That's called a continuous chip that's firing away. And what we have there is that we have a clearance angle created at the very tip. So as we reach the centre, we're not left with any pip, and the tool height is correct on centre. That is absolutely perfect. And now we've reached the centre point, we've gone slightly past it, so now we can stop the automatic feed, stop our machine, and then we're checking then that we've got a nice mirrored finish on this side. So that's perfect what we're looking for. What we want to try and avoid at all times is we don't want to avoid this kind of a dull finish that you can get, and what causes that generally is a bad tip, or if you were catching the swarf hook off, scratching the surface of the material. But generally you want to make sure you've got a good cutting tip on your cutter, and then that's to avoid, you want to get this mirrored finish. That's what we're looking for. That's the first side done. Pause. So we've taken our part out, and we're putting it back in now. And what's important here is when you put it in, is to ensure that it's definitely in, up again close to the jaws, and using the hammer to ensure you're back in close, and you don't have a gap in behind those jaws. And any of those jaws, the material is up close to them. Otherwise, it will not be a uniform thickness all the way around. So we're going to again repeat the process, set the tool off, the center, set our Z, power on the machine again, and you're going to machine out the way, back out again, and then you're going to bring down this side to the correct thickness of 13. So before you take a measurement, you want to ensure you've got no saw cuts left. So I'm going to adjust in on our less than half millimeter, engage my automatic feed again, and start machining down the part. I'm applying the coolant onto the tool and not onto the work. So as we're machining, I'm just going to have a quick check to see, stopping the automatic feed, stopping the machine just to see if we got any saw cuts. So what we have here is, as we're cutting, we can clearly see we have not removed all the saw cuts, so we're going to have to make another pass after this one to make sure that all the material is gone. So once we reach this end this pass, we're going to have to make a second cut to make sure all the saw cuts are gone before we take a measurement. So now we can still see some saw cuts, and we haven't got a good finish. We need to take another cut off after that last pass. And now we're going to adjust in again, another half millimeter. Power on the machine. I'm going to face across the piece again. So again, now we're removing that material away. So you can cut up to about 0.8 of a millimeter in a cut, in one cut. So the heavier the chip, the heavier the cut, the material is going to drop into the machine. The lighter the material will cause it to spiral up around the chuck. So it's better to have a heavier cut than a lighter cut to avoid it getting tangled in the chuck. So I'm just going to clearly stop the machine again just to check. But we can clearly see now we're getting this excellent finish. We've removed all the saw cuts, so after this pass, this will be we can take a measurement. We're powering the machine on, and we're continuing on there. That's a continuous chip we're getting coming off there. A lovely continuous chip. And always clearing away and watching machining as using automatic feed. So never at any stage leave the machine unattended. Always stay with your machine, making sure you're watching what you're doing. And concentration on what you're at. So the coolant is flying onto the tool and not onto the work, therefore it's not being splashed around. And we're getting an excellent finish on our part. That's what I call a continuous chip coming off there now. Pause. So we're now continuing on that part, and we're reaching just still at the end of that first pass. Sorry, our second pass on the opposite side. So now we've removed all the saw cuts. So at this stage now again, we're reaching in. Always apply the coolant onto the tool and stay with your machine when using automatic feed. We reach the center point, we've stopped the automatic feed, stop our lathe, and now we check again, we've got an excellent finish on both sides. So now we're going to 0 to Z. Tool is touching the work. We have a reference point set in our Z. So you can take out your vernier calipers and now take a measurement. And what you want to see here is measure your vernier calipers, taking the check, 15.58, and you have to bring it down to 13, whatever yours measures, if it's slightly more or slightly less. And then what you want to see is a uniform thickness all the way around, like we're seeing there, 15.58, 15.58, 15.58, all the way around. And then we need to bring down 2.58 off that to get it down to its correct thickness. So don't cut it all at once, you just really have to come out, taking it as passes, in multiple passes to get down to your side, to your correct thickness. For the purpose of the videoing, I'm going to let you continue on with that purpose. I'm going to move on now to this next stage, which will be drilling the hole. Get down to the correct thickness here, according to your drawing. So you're going to get the thickness of this part now set to be 13. Okay, pause. Okay, the next stage now is we're going to get ready to drill this hole, and the hole we're drilling here is only so we can turn down the outside diameter. If you look at the current setup, you can clearly see that it's not possible to machine the outside diameter of the material. So what we're going to have to do is we're going to hold this material, we're going to drill a hole, 19.5, ream at 20, so it fits in this fixture. We're going to grip this fixture in the chuck, and then that will allow us to clamp in multiple parts, multiple discs together, and turn down the outside diameter of 5-6 discs at the same time to get the outside diameter to 150. At the moment we can't machine the outside diameter because you can clearly see the jaws are holding against on the material. So now it's set up, pause. So the central bits, the first thing it's going to do is going to drill a central bit, a pilot hole. And they come in different sizes, central drill bits, and we're going for one of the largest ones here that'll fit into the chuck of our drill. So we're going to go up there for a number 6, number 7. Taking your chuck, pause. Central drill the hole with the correct size of placing to the chuck, and now we're going to prepare for central drilling. So the speed set for the central drilling is at 540 RPM. We're pushing forward into position, and remember from before, previous videos, you apply the lock on to this tailstock, power on our lathe, and you're drilling forward, applying coolant down to the drill bit. Here, as we're going to drill a 19.5, we're going to go right in with that central bit to create a good sized pilot hole. We've done that now, and now we can replace out the chuck by popping our 19.5 drill bit. Again, calculate out your speeds for the 19.5. But as you're in training, we're going to leave that speed today at 540 RPM. So powering on the lathe again, powering on our lock, and you're drilling in. And important here is to keep drilling, don't pause. If you pause, you get a high-pitched screech. So as you're boring in, you're going straight through. But don't pause, keep drilling, keep moving, keep feeding on the tailstock to avoid that screeching noise. The 19.5 is drilled. The next thing now is to replace out. So to remove out the drill every time, I'm just winding back on the tailstock and it pops the tool out. Finally then, the 20 reamer, you put it in position, you wind forward again, 56 millimeters, and slot it in position. The speed is staying at the same as we're in training at 540 RPM. Applying on our lock, leave off the quill lock when you're drilling, don't have the quill lock on, that will stop you from drilling. Powering on the lathe, and you're drilling in, only removing a half millimeter, so it's twice as fast to feed, and we have a feed. And back out. And that's the process done. So now we're ready now to go put our part, and you hand it to a member of staff, we'll pop it onto, take it out of here, pop it onto the fixture, and get ready to machine. So as it comes out from there, it's just going to pop on inside and slide into position. And then we'll, after multiple ones of these together, allow us to machine the outside diameter down to 150.